this rule, this function rule. So our pattern, as our x's are going by ones, from one number to the next, 1, 4, 7, 10. We're going up each time by 3. 4 plus 7 is 3. 7 plus 10 is 3. So we are taking our x's and we're going up by 3 each time. So our rule or our pattern is we're going up by 3. So if that's the case, if I plug in a 1 here, 3 times 1 would give me 3. Well, if I plug in a 1, I should get out a 1, not a 3. So what do I need to do to that so that this is a 1? Well, I would have to subtract 2. So if we add or subtract to our rule, subtracting 2, let's see if that works now. If we plug in a 1, we should get out a 1. 3 times 1 minus 2, well, 3 times 1 is 3. 3 minus 2 is 1. That works. Let's try another number. If I instead plug in a 2, I should get out a 4. 3 times 2 is 6. 6 minus 2 is 4. It works. So how did I figure out that this is going to need to be a minus 2? If I take my table and I work backwards, instead of adding 3 this way, if I went the opposite way until I get to 0 in my table, going the other direction would be subtracting 3. 1 minus 3 is negative 2. So that's where that negative 2 really is. It's where my input is 0. Just like back here, my input was 0, my output was 2. That's why we have a plus 2 on this equation. Let's try a couple more. We're doing the same thing, they're just different letters, R and T. So if you want to instead make them X and Y, that's fine. This is really X, this is really Y. So we're trying to find out Y or T, whatever letter you want to use. The tricky part on this one, though, is that our inputs don't go by ones. So you need to just find a place where they do go by ones, or find what would go directly in the middle. Between 0 and 2, we would have 1. Directly between 1 and 7, if I subtract them, 7 minus 1 is 6. So there's 6 numbers between here. Half of that would be 3. So 1 plus 3 is 4. Does that work again? If I add 3, 4 plus 3 is 7. So yes, all I did was subtract and figure out what would be halfway between those two numbers. Let me do that again here. 7 minus 1 gave me 6, so there's 6 numbers between 1 and 7. So halfway between would be 3 numbers from one or the other. So if I add 3 to 1, I get 4. Same thing, 4 plus 3 would give me 7. If I continue, I could put a 3 between here. 7 plus 3 would give me 10. Plus 3 is 13. I'm just going to ignore this last one because I don't even want to figure out how many numbers are between 4 and 9. It's way too much work. And I really don't need it because I actually figured out my pattern. My rule is that I'm adding 3. So 3 times whatever x is. And then let's see if that works. If I plug in a 0, I should get out a 1. Well, 3 times 0 is not 0. Or 3 times 0 is 0. It's not going to give me 1. So I need to add 1. Or just look, when x is 0, y is 1. That's the easiest way you're going to figure out your function rule or your equation. Oops. Let's try our next one. We have our function. We need to figure out what's our pattern from one number to the next. These are really 1, 2, 3. They're in order, so we're good to just look from one number to the next. This one we're going down by 5 each time. So we have negative 5x. And then looking when x is 0, y is also 0. If you want to put plus 0, you can. You don't need to. Alright? So basically, this number out front is our pattern. And the number on the end is what is y when x is 0. It took us a while to get there, but hopefully we figured out our pattern. We have one last slide. It's just going back to what we started with tell whether the relation is a function. For every input, there should be one output. So we have 1, 2, 3, those are all different. So yes, this is a function. Each input has one output. This next one though, 9, 9, 25, 25, here we have a problem and here we have a problem. We have two problems here. So this one would be not a function because there is more than one output for 9 and, oops, that's a 9, and 25. Let's rewrite that. 9 and 25. All right, your homework is